Hello, and we are now on our Module 2, Lecture 2 of our online class. Now, our topic for today is all about the basics or the foundation of bonding and molecular structure of organic chemistry. Now, this topic is, I assume, was thoroughly discussed in your lecture. So, pahapyawan ko lang siya kung ano lang ba ang mga essentials na i-discuss natin throughout this lab. Now, before I discuss the experiment kasi, kailangan ko munang i-discuss ito para naman na iba to o sa inyo yung topic at nang hindi kayo nangangapa naman kahit papaano. So therefore, let's now start our discussion. In the outline of our topic for this module is all about the history of organic chemistry, the atomic structure. We will discard the quantum numbers because this was thoroughly discussed in lecture, covalent and ionic bonding, and Lewis structure. Now, what is organic chemistry? Organic chemistry is the study of carbon and its compounds. Now, nung 19th century daw kasi, organic compounds were only came from the living organism. Noon, yan yung concept dati, also known as the vitalism through the vital force theory. And sabi doon dati is the only living things could synthesize organic compounds through vital force. So therefore, organic to organic can only synthesize organic compounds can only be synthesized by organic substances. Now, it was debunked by Friedrich Wöhler, a German chemist noong 1828 kasi through his experiment, hinit niya yung ammonium cyanide which is inorganic. Hinit niya at nag-form siya ng urea which is organic. And we all know that urea is the component of a fertilizer. So he debunked that vital force theory kasi from inorganic, he synthesized a organic compound. So nawala ang concept na vital force theory, and therefore the modern definition of our organic chemistry is now the study of carbon and its compounds. Now, ang organic chemistry natin guys is applicable din, related siya sa ating mga natural products. And ito, we all know that the vitamin C is an organic compounds that is found in various citrus fruits. Kasi nga, it contains a long chain of carbon na may carbon double bond O, carbonyl compounds, and some sort of alcohol and alkenes. Now ito is classified as organic compounds. Now, this is an article and I suggest that you read it kasi ito ang applications mostly ng ating organic chemistry natin. Now, there are two types of organic compounds. You all know that is that a synthesized or the artificial and the natural. But the structure of the organic compounds is also the same. Nagkakaiba lang dun sa may impurities kaya nagkaroon ng side effects. Now, it was discussed thoroughly sa may pharmacology ninyo kung madidiscuss ninyo sa may BetMed. Now, let's go on to the atomic structure. Ano ba yung atoms natin? Okay, yung atoms natin is yung pinakamaliit na ano ba ang tamang term doon? Na matter na mag-exist sa universe because tingnan niyo ito. From the biomass or ecosystem, biocenosis population, organism, system of organs, organ, tissue, cell organelles, molecule, and atom. So atom is the smallest matter. Siyempre, i-discard natin yung mga protons, neutrons, and electrons, and the quarks na nag-exist dun sa may atoms natin. But the idea here is the atom is the smallest matter in the natin. Kung i-compare nyo sa may organization of living things natin. Yan. So, ano ba ang different models of atoms? Here are the different models of atoms by Plum-Padding model, the Bohr atom by Niels Bohr, and the planetary model by Ernest Rutherford. But the most accepted model of the atom is the quantum mechanical model by Erwin Schrödinger. Now, that is the atomic structure. Now, the elements, the atomic structure, the atoms ang binubuo niya is elements. Elements ang binubuo niya. So, elements therefore is made of atoms, which atoms compose of protons, neutrons, and electrons, which protons is positively charged, neutron is the neutral charge, and the electron is the negatively charged. Now, dito sa may quantum mechanical model na to, ano bang difference dito sa mga ito? Sa may Plum-Padding model kasi sabi ni J.G. Thomson is magkasama daw yung electrons and protons doon sa may spherical cloud. And then dito naman kay Niels Bohr is umiikot daw yung ating mga electrons throughout the, anong tinatawag natin dito? Yung orbitals. In the planetary model, same concept, pero iba yung pan natin dito. But ang most accepted nga is the Erwin-Schrödinger na kung saan yung hindi natin alam yung definite location ng mga electrons natin. Kaya nga meron tayong Heisenberg uncertainty principle and some sort of Schrödinger equation. Kaya ganun. So we do not know the exact location of the electrons in an atoms. Unlike kay Niels Bohr, umiikot-ikot lang daw siya. So diniscuss ko lang siya. And therefore, balik na tayo sa discussion natin is pinasadahan ko lang. Nagpasaali lang ako. Distinguished by its atomic number. Now, doon sa may atomic number natin is makikita nyo naman siya sa ating periodic table. Diyan na di-distinguish yung ating mga elements. Which the atomic number natin is the number of protons and electrons surrounding the nucleus, which is the atomic number. Now, how do I calculate for the number of neutrons? Kung unin nyo lang yung mass number and i-minus nyo lang yung number of protons, you will get the number of neutrons. But it was discussed sa inyong general chemistry, so hindi natin siya ito thoroughly discuss dito kasi papasadahan ko nga lang. Now, when two elements are combined, it is also known as compounds. Now, these are the periodic table of elements na in-arrange ni Dmitry Mendeleev. Ayan. These are our modern periodic table of elements na minemorize ninyo noong kayo high school pa or senior high school. Okay. Yan na siya. Now that, ayan, so news lang siya. So di ba nga, ganun ko sinabi ko kanina that the protons and neutrons kasi is yun yung composed. The nucleus is composed of protons and neutrons. Samantalang electrons naman natin is pagala-gala lang siya. So wala siyang partner. Kaya kawawa naman siya dito. Unlike si proton and neutron, ayun, magkadikit sila, naghahalikan. So mapapasana ulit na lang ng electron. So ganun. And sabi dito, do not trust atoms because they make up everything. Ha ha ha. Sige, lumanan joke na. Sige. Now, when we have this concept of isotope here, it is the existence of same element that have different masses. Same atomic number, same atomic weight. The common example nito is yung ating carbon. We have carbon 12, which is a mass number of 12 na makikita ninyo sa periodic table. But when you add, I take 2 neutrons here, siya ay magiging carbon 14 na kung saan yun yung ginagamit natin for carbon dating. So nagkaroon tayo ng isotope. But the number of protons in here is also the same, which is 6. Hindi lang siya nakalagay. And also with the carbon. So isotope. Different mass number, same atomic number. So nagdi-differ siya sa may number of protons dun sa may nucleus natin. Now here, sa may atoms natin kasi is we have the so-called valence electron or the outermost shell of the atom. Consists of electrons that are ones that is responsible for the chemical bonding. The number of valence electron can be identified by looking at the group number of the element. So let's say here, di ba sa may electron configuration nito is we have lithium which has a electron configuration of 1s2 and 2s1. Now, ano ba ang group ng ating lithium? Kung titingnan nyo sa ating periodic table, kung babalikan natin kanina, is that's why I require you habang nagkaklase or habang nakikinig ito is dapat may hakong periodic table. So, the lithium is group 1. So, therefore, ang number of valence electron niya is 1. And we also have fluorine. Ayan. So, group niya is group 7. So, therefore, the number of valence electron in its outermost shell is also 7. Now, combine this one, siya ay magiging lithium chloride, which is also known as the ionic bonding na madidiscuss natin mamaya. So, again, here is the picture of the modern periodic table of the elements. Now, punta naman tayo sa may orbitals and electron configuration. Okay, ito is, I will skip this part kasi na-discuss siya sa may lecture ninyo and ito ay hindi naman essential sa ating laboratory. So I'll skip this part. And besides, yung mga electron configuration naman natin is naalagay naman siya sa may periodic table natin. And meron siyang mnemonics doon na naalagay para ma-identify nyo yung electron configuration ng specific element natin. So there's one here, the principles, the Aufbau, the Pauli exclusion principle, and the Hans rule. Ayan. Pero sige, discuss ko na rin. The electron configuration is governed by the 3 rules. Una-una is the Aufbau principle. Now, lowest energy first daw muna ang mag-field ng electron natin. So, kaya nga meron tayong concept na 1s1, na 1s, 2s, 2p, kasi yun ay increasing energy. Siyempre, when you have a 1s, 2p, okay, I will do some bit here. Let's say we have a 1s, 2s, and 3s. Siyempre, unang-una yung pipila pa ng electrons is the 1s, before yung 2s, and before the 2p. Because kasi yan yung pan natin. Ayan yung unang mag-field because lowest energy as described by the AFBA principle. And dun sa may Pauli exclusion principle naman is when you see here, meron kasi tayong, for example, sa may 2p electrons natin is we have in arrow. Now dito, dalawang electrons lang daw yung pwede natin in a orbital. Dalawang electrons. But before we go on to the Pauli exclusion principle, punta muna tayo kay Hans rule. Simple lang naman yung sinasabing Hans rule is that pag daw nag-field ka ng electrons, let's say you have a 2p4, so 2 p orbital is a 3 orbitals here. Now, syempre, ang Hans rule dito is, for example, kailangan mo munang fill upan yung mga natin. Paisa-isa lang muna. Hindi ka pwedeng, let's say, 2p4, kunwari, ganyan. Tapos, tsaka ka lang mag-fill up dito once na na-occupy na lahat yung dalawa yun. Hindi ka pwedeng kumanito, 2p1, 2p2, and then tsaka ka lang mag-gaganito. Hindi. Half-half field muna bago mag-field dun sa may isang electron. Now, dun ang principle naman is Pauli exclusion principle is that only 2 electrons can only occupied by an orbital. Only pataas and pababa, wala na tayong pagilid. Only pataas and pababa lang. Or yung electron spin natin, if we discuss this thoroughly, that is also known as the positive and negative, which is the spin quantum number. Okay, Hans rule. And these are the specific electron configuration here na na-discuss, I think, sa may lecture ninyo. This one here. Lowest energy first, 2 electrons by Pauli exclusion principle, AFBA principle, and Hans rule na half field muna bago mag-field doon sa may ikalawa, bago bumaba. Napunta naman tayo sa may chemical bonds or the octet rule. Here are the specific structure of some pesticides na makikita natin sa ating agriculture. Itong mga to, so paano ba nangyari yun? Ayan, how do we do that? Now, before tayo magkaroon ng chemical bonds or octet rule, let's have first, ano ba ang 2 types of chemical bond? There are 2 types of chemical bond. The ionic bonding, which is the transfer of electrons from one atom to another, and the covalent bond, when 2 atoms share electrons. Now, the idea here, guys, is it must obey an noble gas configuration to achieve a stable configuration, the most stable state of an atom. That's why meron tayong octet rule. Ionic bond, transfer of electrons. Covalent bond is the sharing of electrons. Napunta naman tayo sa may ionic bonding. As discussed, sinabi natin kanina, it is the transfer of electrons. Now, consider this sodium proposing to chlorine. Okay. Now, sabi ni sodium, chlorine, will you accept my electrons to form an ionic bond with me so that we can be a sodium chloride? And the answer is yes. Siyempre, sino ba naman dito naging electrons yan? At sila po ay naging asin. Yun. Sila po ay naging asin after forming an ionic bond of sodium and chlorine. So, paano ba nag-occurs yung ionic bonding natin? Is yung atoms kasi natin may gain a charge, also known as ions. When I said sodium, lose an electrons, syempre, we all know that the electrons is negatively charged. So therefore, once na nag-decrease ka ng negative, siya ay magiging positive. So therefore, an ionic bond is the attractive force between oppositely charged ions. Now here, as we can see here, guys, kung mapapansin ninyo, is kung titignan niyo kasi sa periodic table, when, for example, you have a lithium fluoride bonding, mangyayari dito is titignan ninyo yung concept of electronegativity. And by the way, yung ionic bonding natin is nakita naman sa periodic table. So, makakanya lang yan. Formation lang ng cations and ng ions. Now here, consider this. the formation of lithium fluoride ion. Now, paano ba nangyari doon? The lithium will transfer an electron to fluorine in order to form a lithium fluoride. But in the aqueous solution, the lithium form a positively charged product. Kasi nga, nawalan siya ng negatively charged. And we all know that the electron is a negatively charged. So therefore, from neutral, nawalan siya ng negative, siya ay magiging positive 1, which makes it neutral. Ngayon dito, since yung electrons, dito naman sa may fluorine, si lithium kasi binigyan niya electrons. So, nagkaroon siya ng excess negatively charged. So, mag-adagdag ka ng negative, siya ay magiging negatively charged. Formation of lithium fluoride. And titignan din ninyo also the concept of electronegativity. Fluorine is more electronegative than the lithium. So therefore, lithium will transfer its electron to the fluoride. By which fluorine, again, will attract the electron of lithium. So, madaming concepts na pinagdadaanan dyan. And by the way, kung hindi kayo familiar sa concept of electronegativity, the ability of an atom to attract electrons by themselves. So, nakikita naman yung values dyan sa ating periodic table. So, ayan. So, mga ganyan, the electronegative is based dun sa may arbitrary scale by which when you go from right to left of the periodic table, mas tumataas yung electronegativity, and from bottom to top, yun, mataas yung electronegativity natin. Now here, ito pala, nandito naman pala yung sinasabi ko. So, here, from left to right, tumataas yung electronegativity natin across the periodic table. And from bottom to top is tumataas din yung electronegativity natin. So, that is the trend of electronegativity. Ganyan yung magiging mana. And by the way, it's always constant and given naman siya sa may periodic table. Hindi nyo siya kailangan i-memorize, guys. Kasi kaya nga ginawa ang periodic table para hindi nyo i-memorize yung mga values, constant values na nandoon per element. So here, ayun. Anyway, okay. These are the ionic bonding of the sodium chloride here. So nagkaroon. Nawalan siya ng shell dito. We all know that the sodium is a group 1. So mag-transfer siya in order to form a 3p6 electron configuration from the sodium. Now the idea here, guys, is once the atoms gains a positively charged, mababawasan yung electron, mababawasan din yung electron configuration. And also the reverse effect of this is when an atom gains an electron, madadagdagan yung outermost shell niya, ng electron. For example, this chlorine from 3p5 to 3p6. So that's 8. That's 8. So therefore, na-achieve nila yung sinasabi natin kanina, sana yun, di ba? Chemical bonding is yung ating octet rule. The octet rule. But octet rule, kasi nga from the word oct, na-achieve niya yung 8 rule natin. So that's our natin. Now, these are the common charges of the monoatomic ions kapag sila ay nag-gain or nag-lose ng mga electrons. So these are here. Sir, saan po ba nakikita itong mga to? Kailan po ba namin memorize? No, nandun siya sa may periodic table natin. Okay, now we're done with the ionic bonding. Dito ngayon papasok yung Lewis structure natin sa may covalent bonding. Covalent bonding is related to Lewis structure because it is a sharing of electrons between atoms to achieve a noble gas configuration. Now, dito sa may Lewis structure natin or covalent bonding, there are 4 representation. Unang-una, yung electron dot formula, the condensed formula, the dash line formula, the bond line formula, and ito is, sorry din guys, the ball and stick model, which is yan yung 3D representation ng ating mga Lewis structure or the organic compounds. And by the way, the ball and stick model and the bond line formula is only applicable to the organic compounds. Wala po kayong makikita na skeletal structure or ball and stick model na mga inorganic compounds na sobrang haba unless gagawin nyo siya. Pero the most common is, ayun. So consider the following problem. Decide whether the bond in them would be ionic or covalent. Wow, sasagutan daw natin. Okay, letter A. Letter A. Ano yung sagot? R-will? Okay, sir, yan po ay ionic bonding. Bakit siya naging ionic bonding? Kasi nga, using some makikita nyo naman kasi yung potassium ion sa periodic table and chlorine ion sa periodic table natin. So therefore, potassium is an cation and chlorine is an anion. So ayan, cation and ion will form an ionic bond. So this one, A is ionic. B, okay, wala naman tayong FF. So automatically that is covalent bonding. This one is also covalent bonding. Covalent bonding din ito guys because it is a sharing of electron. This is also a covalent bonding kasi ito ay sharing of electrons. Now dito, bakit ito naging covalent bonding? Kasi nga, siya ay nag-share ng electrons between hydrogen. And besides, pwede rin siya maging ionic, pero by calculating its electronegativity difference of phosphorus and hydrogen. So alamin nyo na lang, feeling ko siya ay nasa gitna. Yun, yung mga ganun. So, ionic, covalent, covalent, covalent. So, that's it. Now, dito na tayo pupunta is how to write a Lewis structure for the natin. Writing a Lewis structure. So, consider this. Kapag nag-write ka ng Lewis structure, there are two representations kasi. It's either the electron dot or the dashed line formula. Okay, so ayan, pwede siyang ganito, pwede siyang ganito. Pero I highly recommend sa gagamitin natin sa klase natin na magkaaroon sa mix ninyo, is gagamitin ninyo yung ating dash line formula. So the Lewis structure, ayan, is composed of dash, the atoms, and the lone pairs. Okay, now paano ba natin malalaman yan? Okay, consider this methane, C2H6. Okay, para mag-drawing. Pero, ayan. C2H6, tandaan niyo guys, is dapat niyo malaman muna yung central atom and the bonded atoms dito. So, paano ba nangyayari yan? The C2H6 natin. C2H6 natin. So, C2H6. Guys, lagi ninyong tatandaan that the carbon is the central atom sa ating organic compounds. Now, since meron siyang also known as the catenation property, so automatically, ibaban nyo yung dalawang carbon na yan. So, carbon is always a central atom. And hydrogen, sorry, ano na yung andito? C2H6. C2H6. Now, the hydrogen here is ibaban nyo lang siya ng ganyan. So, i-discuss natin yan thoroughly mamaya. Pero pinakita ko lang yung typical example. Alam ko naguguluhan kayo guys, pero mamaya natin siya i-discuss thoroughly. So ayan, here, the periodic table of elements. So, draw the Lewis structure of the following compounds. Okay. Sagutan natin yung A, B, and C. Okay. Sagutan natin yung A, B, and C. Ano daw yung ating A, B, and C? Now, yung letter A natin, guys, is letter E natin is the ammonia. Letter B is water. And letter C is hydronium ion. Now, ano ba? Unahin natin yung ating ammonia. How do we draw the Lewis structure of ammonia? Now, first and foremost, alamin ninyo yung central atom. Ano ba yung central atom natin dito, guys? Siyempre, yung nag-iisa, which is N. So, ayan. Now, yung pan natin dito is yung hydrogen natin is tatlo. So, automatically, ibabanding nyo siya dito sa may tatlong NH natin. Ganyan. Now, meron tayong dalawang lone pairs dito. So, paano ba nangyari yan? Yung N kasi natin is group 5. So, therefore, di ba, sinabi natin kanina is the number of valence shell electron natin. So, therefore, group 5. Kung ano yung group number niya, yun yung number ng Lewis niya. So, 1, 2, 3, 4, 5. And yung hydrogen natin is only group 1. So, it's only have a 1 Lewis dot. 1 Lewis dot lang ang meron sa atin. So, therefore, guys, ang mangyayari ngayon dito, kaya hindi pwedeng maging central atom yung hydrogen natin. Kasi nga, is meron lang siyang, it's only capable of 1 bond. So, i-occupy natin yung pan natin, gugulhin ko muna, scratch lang to. Yung ammonia natin, dito yung isang H, di ba? Meron tayong NH3. Dito yung isang H. And dito yung isang H. So, meron pa tayong natitirang dalawang bonding. Dalawang lone pair dyan. Now, ayusin natin siya by following a geometric patterns, yung geometry natin. So, ganito ang mangyari natin. Now, does this central atom obey an octet rule? Yes, kasi, tandaan niyo guys, kapag nag-electron counting tayo, the bonding here is count as 2. Di ba? Kapag ni-represent siya sa may Lewis dot structure natin. So, there are 2, 4, 6, 7, and 8. So, 8. So, na-achieve niya yung octet rule natin. So, therefore, this one here is the proper Lewis structure of our ammonia. Napunta naman tayo sa may letter B natin. What is the Lewis structure of H2O? Siyempre, first and foremost, know the central atom. We all know that the kwan, kasi dito sa may ammonia na una N. So, siya yung central atom. Sir, nauna naman dito yung yung H. So, ito ba yung H natin sa central atom? No. Aalamin ninyo yung nag-iisang atom na nag-exist doon sa may compound natin or element. So, the O is our central atom na may nakaband na dalawang hydrogen. So, H, by following a proper geometry, so ayan. So, meron siyang dalawang apat na Lewis dot dito. Sir, paano po nangyari yan? Di ba? We all know that the oxygen, anong group siya? Siya ay group 6 sa periodic table natin. So, it has a 6 Lewis dots. Yung hydrogen naman natin is only group 1. So, therefore, 1. So, magko-combine dito. Ayan. And ayan. Ilan yung natira? 4. Okay, this is only a scratch. So, we will follow the proper geometry. Ganun. Sir, does the central atom of the octet rule? The answer is yes. Kung mag-electron counting tayo dito is 2, 4, 5, 6, 7, 8. So therefore, 8. It obeys octet rule. So therefore, this is the Lewis structure of our H2O or water. Sir, what about the hydronium ion, sir? Meron po siyang charge. Okay, ganito ang mangyayari dyan. Sa hydronium ion natin is letter C, hydronium ion. Ayan. Hydronium ion. Okay, punta na natin. Now, here, we all know, ito yung nag-iisa, siya central atom, so therefore, O. And nakaband daw yung tatlong hydrogen. Following a proper geometry, ganito yung magiging itsura niya. But positively charged po siya. Ano po mangyari dito? Ang mangyari kasi dito, guys, is ilan yung magiging water natin, ilan yung magiging Lewis dot niya is, ano ba yung O natin? Group 6. So, 1, 2, 3, 4, 5, 6. Now, since positively charged, mawawala yung isang electron natin dito. Mawawala yung isang electron natin. Wait lang. Mawawala yung isang electron natin. So, tanggalin natin to. Siya ay 5 na lang. Since there are 3 hydrogen, which is group 1, so 1, 2, 3. So, ayan. Following the proper geometry, so ilan yung Lewis dot niya? That is 2. Ayan. And don't forget, guys, kapag magsusulat kayo ng charge, is i-include nyo siya dito. Pag ganyan. Sir, does the central atom of the octet rule? The answer is yes, kasi 2, 4, 6, 7, 8. So, it obeys an octet rule. So, this is the Lewis structure of our hydronium ion. So, ganyan. And here are the others. Pag-practicean nyo lang guys sa mga bahay-bahay ninyo kasi posible siyang lumabas sa may quiz natin. Okay, now let's proceed to our discussion paper para matuloy na natin. Yan, guys. Okay, let's do this. Next, also possible din sa atin yung multiple bonding sa ating carbon compounds. Consider this ethylene, formaldehyde, and formaldimine. Okay, punta tayo sa example. So, there are also a triple bonding. So, multiple bonding can also occur from our sa ating Lewis structure. So, these are the common bonding patterns na charge here. So, that's kapag 4 bonding, that is tetravalent, 2 bonding divalent, and this R is the monovalent. So lone pair of electrons, that is just a transfer. So na-discuss ko na yan kanina. So punta naman tayo sa may isomers, yung importance of structural formulas natin. So I will skip to this part kasi I assume na na-discuss naman siya sa may lecture ninyo. At hindi naman siya pag-uusapan sa may laboratory natin. So ayan. Also chemical bonding, octet rule. We will skip to this part again. And by the way, guys, sabihin ko lang, is there are also exceptions to the octet rule. Ano ba yung ibig sabihin nun? Ang mangyayari kasi doon is meron tayong nag-exceed at hindi sumusunod sa octet rule. It's either 6 bonding or more than 8 ang nangyayari sa kanya. Consider this phosphorus here. There are 10 electrons in the phosphorus kasi nga, di ba? So, na-violate niya yung octet rule natin. Also din dito, there are 16. Now, dito is matatail naman yan sa may advanced topics in organic chemistry due to the presence of the orbitals of these compounds. Kaya nila na-violate yung octet rule. And dito naman sa may isa natin is, kung makapansin ninyo, is kulang. Kasi nga yung boron natin is only group 3, so it is only capable of third bonding unless lalagyan mo siya ng positively charged dito sa may natin. So sa may formal charges naman natin is na-alkylate naman yan sa may lecture. Pero meron na akong shortcut formula. And lalabas din ito sa may quiz natin. And pahapyawan ko siya. Pahapyawan, pero lalabas sa quiz. Ang kan kasi dito is meron tayong formula dito. Pero hindi ko siya sinusunod. But rather, I devise my own formula here in order to calculate the formal charge of the atoms. So ganyan. Ang formula ko dito, guys, is ang andito, may formula ko dito. For example, ayan, for example, is ammonia. Ano ba natin i-calculate yung ammonia? Is, ang kwan ko lang dito, ang formula lang dito is the formal charge is equals to group number or Gn minus the number of bonds here and minus the number of electrons. Mamaya, sa may part po ng lecture natin is matatail natin. So this is the formal charge natin. Kaysa dito sa may isa na to is magka-calculate ka pa ng natin. Kung anik-anik pa, magdi-divide ka pa ng 2. So ganyan. Formal charge of N in the ammonia. So we'll skip this part. Nitrate ion, 6 here. Formal charge of O. Ayan, some sort of natin. So 0, 0. And these are the summary of some formal charges of the natin. Okay. So sa resonance theory naman is natin resonance theory is the natin ito yung mga different structures ng mga same compounds natin or the movement of electrons in an atom. So paano ba nangyayari yan? Consider this structure of carbonate ions natin. Kung mapapansin niyo guys is there are 3 different structures na kung saan yung electrons natin or yung negatively charged is palipat-lipat ng mga natin. Palipat-lipat yung electrons natin. This is not the same structure kasi nga we have a designation of oxygen in each atom. Kaya, iba-iba ang structure niya. Iba-iba. So, ganyan. So, these are the concepts here. How to write Lewis resonance structure. So, we'll skip to this part again. So, do you have any questions and clarifications so far? Kung may question kayo is kindly PM me doon sa may messenger or sa may Google. I think wag na kayo mag-email sa akin kasi hindi ko siya nasasagot. Hindi ako nanonotify na lang. But rather, i-PM nyo lang ako if wala kayo naintindihan. Now, I know guys, sumakit yung ulo nyo. At kayo'y naguguluhan kung ano ba yung mga pinag-discuss natin sa maka natin. Ang diniscuss kasi natin guys is all about the Lewis structure, formal charges, the bond line formula, and the resonance structure. And this one will be discussed on the part 2 of our lecture. Now, this ends our discussion. So, punta lang muna tayo sa may part 2 ng ating discussion which involves the solving of this sample problem para makapag-refresh tayo. So, here. See you on the part 2.